So let x be a continuous random variable. Well, we can use z, which is defined as x minus mu divided by sigma. Okay, we use this machine, x gets into this machine, and you get your z as the value. So x is your input, x as the input, the machine, x minus mean divided by sigma, and it gives you z values. All right, well, now I expect you to ask, what if I have z and I want to know what was the actual data? What was the actual number that I was working with? Okay. Now, suppose x is not given. What is given? Z is given. To find your x, the x value, we use just a simple algebra. Multiply sigma and z and add mu to both sides. So z times sigma is equal to x minus mu. So x becomes z sigma plus mu. So take a look at this. Now you just enter your z value. Z is the input, and the formula that you're going to use is z sigma plus mu. Z sigma sigma z plus mu, and it gives your x back. So you're going to get your x back as the output. This is your input, and this is your output. Okay. So I give you two formulas, two machines that you can use to either find your z, or if z is given, you can find your x value. Let's take a look at a couple of examples to get more comfortable about what's happening here. Okay, perfect. Let's ask a volunteer from group 3 to read the example for us. Very good. So in this example, you have a weight records of the weights of the cats. You do not have the actual weights. What do you have are the z-scores. So when you see 1.96, it says, hey, my z-score of the weight is 1.96. And it says, I have a negative weight. Guys, the actual weight cannot be negative. Even a dead cat has some, weight. So if you have a negative sign and it says, hey, it's a weight, it means that you're dealing with the z-score. You do not have the actual x values. Well, it says, hey, z is equal to 0. Okay, it means that you're standardized. Z is given. It means that we're looking for our x value. Let's take a look at the board. On the board, we have the following machine. It says my x is nothing but z times sigma plus mu. It means that I enter my z into this machine, and it gives me the weight or the output back, all right? So let's do the computations. Let's go to our little board here. Just erase it and do the computation. Okay, perfect. So again, now we have our z. They go into the box and you get your x values back. Z times sigma plus mu, and you get your x values, the actual weights back, x values. Okay. What is the first z value? The very first z value is 1.96. So what is x? X is z times sigma plus mean. But do I have information about mean? Well, it says, hey, mean weight is 9 and the standard deviation is 2 pounds. I have this information. So my x, the weight of the cat, is 1.96 times sigma, which is 2, plus, you copy down the plus sign, mean is 9. What is the weight of that cat? The second one, z is negative 0.44. I want to know what is the weight associated to this z value. I have a formula, z times sigma plus the mean. X is z negative 0.44 times sigma, which is 2, plus the mean, which is 9. What is my weight? And finally, the last cat with z equals to 0. What is the weight of that cat? X is z times sigma plus mean. So x becomes 0 times 2 plus 9. Okay. By doing the computation, the very first weight is about 13 pounds, 12.92 pounds. The actual weight of the cat. Excellent. The second one is associated to x equals to 8.12 pounds, the weight of the second cat. And finally, the weight of the last cat is just 0, so it's going to be 9 pounds. X value. So that's how we find the x values when the z is given to us. So the score for the standard test, normally distributed. The mean of that test is 50 and the standard deviation is 10. Well, the applicant to be considered for higher, they need to have scores in the top 10%. Well, what is the lowest score that a person, an applicant, can earn and still be eligible to be hired by that agency? So we want to know what is the x value, right? What do we have? We have the mean, we have the standard deviation, and we want to know what is that x value. If we go back to the board, if we take a look at our board, it says, hey, if you have your z, you can find your x value. Again, if you look at the larger board, if you have your z, then you can find your x value. You can enter your z to this formula, sigma times z plus mu, and find your x value. But here we don't have the value for z. What do we have? We have the top 10%. The question is, well, how can I use this probability 10% and find the z associated to that 10%. So let me go to the board and explain that for you. So in many cases, we have the probability. Again, guys, when we're talking about the probability, we're talking about the area below the graph. We have the probability. We can use the probability to find the z-scores. The functionality that you're going to use is inverse norm. In our calculator, what you're going to use, you're going to go to second, you're going to go to vars, and then you're going to use the inverse norm. Inverse norm. So again, a quick recall for you. Quick recall. If you're finding the probability that x is less than a, and you have a normal distribution, you're going to go to second, you're going to go to vars, and you're going to use normal C, D, F. Then you have your lower limit, which is like -10, -100, a very small number. You're going to have your upper limit, which is A, the mean, and you have your standard deviation. If it says, hey, the probability that X is larger than B, you're going to follow the same for a normal distribution. A normal distribution. We're going to go to second, vars, normal distribution, normal CDF, and your lower limit is B. Your upper limit is a large number, like 100, 1,000, then the mean and standard deviation. In between is in between. You have your lower limit, you have your upper limit. But this case is different, guys. It says, hey, you do not have your X, you do not have your Z. What do you have? You have the probability. This number, this value is given to you. You can use the probability to find your Z. After you find your Z, then you can find your X. You can find the X value. Well, X value becomes Z times sigma plus 3. So these are the steps that you're going to take. Let me move this a little bit more. See this before. X is Z times sigma plus 3. Very good. Let's go to the board and see what do we have. So in this example, we know that it must be top 10%. Top 10%, where is that located? Let's take a look at your graph. This is my graph, top 10%. Top 10% is going to be here. 10% of 100%, but it is top 10%. Top 10%. Okay, so what is the Z value for top 10%. What is this Z? So first we need to find Z, then we're going to find our X value. Okay, let's use our calculator. To find Z, you're going to use your inverse norm. So go to second, vars, inverse norm. Okay, let's take a look at this. Just turn on the calculator, second vars, and then inverse norm. Inverse norm, well, the area is 10%, okay? So the area is 10%, 0.10, and the mean is 0 because you are trying to find your Z. Mean is 0 with standard deviation 1. So 10%, 0.10, mean is 0, standard deviation is 1. Let's do the paste. The number that is written here is negative because it gives you the Z value on the left-hand side. The calculator computes the area to the left. So since mean is 0, the Z, which is mirror image of negative 1.28, is going to be positive 1.28. Okay, it wasn't that hard. I used second, vars, inverse norm. The calculator computes a negative Z-score, which is the mirror image on the left-hand side, negative 1.28. But since I have the top 10%, this is the below 10%, the lower 10%. This is what your calculator has inside it. It's built into your calculator. Lower 10%. Here you have the top 10%. Your calculator only has the left area, lower 10%. It gives you negative 1.28. So you're going to change the sign into a positive 1.28 and use this Z to compute your X value. So you know that X is equal to sigma times Z. Z times sigma plus the mean, all right? So let's just enter all of this information and find our X. X becomes Z, which is 1.28 times sigma. Sigma is given in the question, all right? It says the standard deviation is 10 and the mean is 50. So if we do the computation, if we just multiply these two numbers and add 50 to it, you get 62.8. So this is the minimum score that still be considered for hiring.